Hi, I'm Dr. Natalie Cruz. I'm the director of the Masters of Sustainability, Security, and Resilience at Ohio University. I'm going to talk for a minute about resilience in energy systems. With a changing climate, we see a lot more extreme weather events, things like the wildfires, cold weather in Texas that in early 2020 knocked out the electric grid, other things that really threaten our electrical system. When we think about how our energy system is built and how to make it more resilient, we have to think about several things. Firstly, we manage the changing demand, supplying enough energy to meet the changing demand in electricity by having excess capacity. In an energy system, we can meet excess demand or increase in demand by either having excess capacity or by having storage. In the US, we tend to have excess capacity rather than additional storage. We can make our system both more sustainable and more resilient by improving our storage in our energy systems. A lot of the storage that we have is pumped hydro storage, where water is pumped up in elevation using excess electricity when supply is greater than demand. And at a time then when demand exceeds supply, that water then runs downhill, driving a hydroelectric turbine and generator to generate additional electricity. There's, of course, some efficiency and loss in energy through that process. And so really increasing the efficiency of storage is a key way of improving the potential for resilience in our energy systems. When we think about some of the energy system failures that we've had due to extreme weather events like wildfires, extreme cold and extreme hot weather, what we need to also consider is how our grid is built and how that then is interlinked with other capacity and other grids. So a really great example of a poorly resilient or an unresilient system is the electrical grid in Texas, where very cold weather in early 2021 knocked out the electrical grid for several reasons. There was poor winterization on many of the plants, and so supply went down as demand went up because of extreme cold weather. Because the Texas grid isn't interlinked with other grids, supply couldn't be diverted from other locations to supply that increased demand in Texas, and so there were major failures. The way that energy market is regulated or is controlled, that also led to inconsistent and unpredictable pricing for both the utility and the consumer, which again impacts that energy system as a whole and what people can afford and how people can use that energy. When we think about wildfire risk, there are actually two sides to resilience and sustainability in that grid, where sparks from electrical infrastructure are one of the causes of some of the wildfires that we see in California, for example. But wildfires can also impact the ability to serve customers with electricity. And so managing wildfires and protecting that infrastructure is key. One key thing that we can do to the electrical grid to improve resilience is to bury lines. So when lines are elevated, they're much more prone to damage from squirrels, from trees falling, from other kind of natural influences that knock out power. And so by having buried lines, particularly in particularly vulnerable areas, you can improve the resilience of that system. Along with buried lines, increased interconnection is a major improvement in the resilience of that energy system. To learn more about sustainability and resilience in energy systems, join us in the online Masters of Sustainability, Security, and Resilience in the Voinovich School at Ohio University.